everyone, I am Abhishek and today we will solve some limits using L'Hopital's rule. So our first question is to find out the limit of x minus sin x into cos x by x cube when x tends to 0. Now here we can see if we put the limits, if we put x equals to 0, it is coming 0 by 0 form. So we are going to use L'Hopital's rule. So for that we need to differentiate both numerator and denominator. Now if we differentiate the numerator part, it will be d dx of x minus d dx of sin x into cos x. Now in this sin x into cos x we need to use the uv formula, and d dx of x is equals to 1, then minus, this is the differentiation of sin x into cos x. So we have differentiation of the first term into the second term plus first term into the differentiation of the second term, which is equals to 1 minus cos square x plus sin square x. Now we know that 1 minus cos square x equals to sin square x. So the numerator will become 2 sin square x. In the denominator it was the differentiation of x cube, which is 3x square. Hence the function will become 2 sin square x by 3x square. Now we can put 2 by 3 outside the limit. So it will become 2 by 3 into limit x tends to 0 sin x by x whole square. Now we know that the limit of sin x by x is equals to 1. Hence the answer will be 2 by 3. Now let us solve the next question. The next question is to find out the limit of x square plus 2 cos x minus 2 by x sin cube x when x tends to 0. Now here also we can see that if we put x equals to 0, we are getting 0 by 0 form. So primarily we can think that we can apply L'Hopital's rule. Yes, we can apply, but if we apply the L'Hopital's rule, we can see the denominator is x sin cube x. So each time if I differentiate it, it will be a complicated function. So I will do one thing, I will divide and multiply x cube in the denominator as I have done here. So here we can see that sin cube x by x cube, and this will become x to the power 4. Now we can distribute the limits. So we can write as limit x tends to 0. Sorry, I forgot to write 0. So limit x tends to 0, x square plus 2 cos x minus 2 by x to the power 4, and into 1 by limit x tends to 0 sin x by x whole cube. Now this sin x by x will become limit as limit x tends to 0 will become 1. So we are getting this expression. Now we can see that x to the power 4 is much more easier to differentiate than x sin cube x. Now this is again a 0 by 0 form. So now we can use the L'Hopital's rule. So if I use that, we can see that it is a differentiation of the numerator and as well as the differentiation of the denominator. So if we differentiate the numerator, it will be 2x minus 2 sin x, and the denominator will be 4x cube. Now from the numerator we can take 2 common, and this 2 will be cancelled out with this 4. So we are getting 1 by 2, and we will put 1 by 2 outside the limit. Hence this is the new expression. Now again we can see if I put x equals to 0, it will give 0 by 0 form. So that means we have to use the L'Hopital's rule again. So this is the L'Hopital's rule, in differentiation of the numerator by differentiation of the denominator. And if we differentiate this function, we are getting 1 minus cos x by the numerator will become 1 minus cos x, and the denominator will become 3x square. So now this 3 will go outside, so it will be 1 by 6 limit x tends to 0. Now 1 minus cos x by this is x square. Now if we put the limits, again we can see it is a 0 by 0 form, because it is 1 minus cos 0 is equals to 1. So 1 minus 1 by 0 square. So it is again 0 by 0 form. Now again we can apply the L'Hopital's rule. So if we differentiate the numerator, it will be sin x, because minus cos x differentiation is sin x, and x square differentiation is 2x, so it will be sin x by 2x, and already outside there is 1 by 6, so this 2 will go outside, so it will become 1 by 12, and this is limit x tends to 0 sin x by x. Now sin x by x is equals to 1, so therefore 1 by 12 is the answer. Now let us solve this next question. So here we have to find out the limit of log of tan 2x to the base tan x when x tends to 0 plus. Now we can see that log of tan 2x to the base tan x can be written as log of tan 2x by log tan x. Here the base of this log is e. So now if I put x tends to 0, it will become infinity by infinity form. So therefore we can write log of limit x tends to 0 plus. Now this is infinity by infinity form. We can use the L'Hopital's rule here. So if we use the L'Hopital's rule, we need to differentiate both numerator and denominator. So this is the differentiation of numerator is log of tan 2x. It will be 1 by tan 2x into differentiation of tan 2x, which is secant square 2x, into differentiation of 2x, which is equals to 2. Similarly, differentiation of log tan x will be 1 by tan x into differentiation of tan x will be secant square x. Now we can take this 2 outside, and we can write this tan x in the numerator and this tan 2x in the denominator. So this expression will become tan x into secant square 2x by tan 2x into secant square x. Now if we put the limits, we are getting this tan x equals to 0 and tan 2x equals to 0, but if we put secant square's the limit of x equals to 0 in this secant square 2x and secant square x, this is coming 1 by 1, so it is not making 0 by 0 form. So better not to involve these two functions. So we will write 2 into limit x tends to 0 plus tan x by tan 2x into limit x tends to 0 plus secant square 2x by secant square x. So I am not involving this limit in the L'Hopital's rule, otherwise it will make unnecessarily big differentiation. So don't forget to write this 2, because when I was solving this question I forgot to write this 2. So it happens if there is any 2 outside the limit, generally we forget to write this 2, this constant. Now limit of this function will be 1, so therefore only this thing is remaining, so therefore 2 into x tends to 0 plus tan x by tan 2x, 2 into x tends to 0 plus tan x by tan 2x. Again we can see it is a 0 by 0 form. So now if I put use L'Hopital's rule, so tan x differentiation will be secant square x and tan 2x differentiation will be secant square 2x into the differentiation of 2x, that is 2. Now these 2 will go outside. Now we can see if we put the limit, so secant square 0 by secant square 0 again, and it will be 1. So this will be 1 and 2 by 2 is 1, hence the limit is 1. Now let us solve this question. Here we have to find out the limit of 1 by x minus 1 by e to the power x minus 1 when x tends to 0. Now if I put x equals to 0, it is coming 1 by x. Since x is tending towards 0, 1 by x will tend towards infinity. Similarly, this is also going to infinity. So therefore this is infinity minus infinity form, another form of indeterminate form. So what we have to do in that case, we will just do the LCM. If we do the LCM here, so it will be e to the power x minus 1 minus x by x into e to the power x minus 1. Now if I put x equals to 0 here, it is coming in 0 by 0 form. So we can use the L'Hopital's rule. So using L'Hopital's rule, we will differentiate the numerator. So it will be e to the power x minus 1, e to the power x minus 1, and then the differentiation of the denominator. So we will use here UV formula. So first I kept that first function as it is. Differentiation of the second function, it will be e to the power x plus, now the differentiation of the first function, which is 1, and kept the second function as it is. Now this is equals to limit x tends to 0. Now what we just simplified this thing, e to the power x minus 1 by, this will be x e to the power x, then plus e to the power x minus 1. So this is plus e to the power x minus 1. Now again if I put x equals to 0, this is coming e to the power 0 means 1 minus 1, this is 0, and if I put here 0, so 0 plus 1, because e to the power 0 is equals to 1 minus 1, so it is again coming 0 by 0 form. So therefore again we will apply the L'Hopital's rule. So if we differentiate the numerator, it will be e to the power x, and if we differentiate the denominator, so it will be x into e to the power x UV formula. First differentiation of x is 1, e to the power x as it is, then x as it is, differentiation of e to the power x is e to the power x. Now plus differentiation of e to the power x is e to the power x, differentiation of 1 is 0. So now if we put x equals to 0, let's see what happens. Because the numerator is not coming 0, e to the power 0 by e to the power 0 plus 0 into e to the power 0 plus e to the power 0. It is coming 1 by 2. Now let us solve this question. Here the limit is 1 by x whole to the power tan x when x tends to 0. Now if we put x equals to x tends to 0, it is coming infinity and this is coming 0. So it is infinity to the power 0 form. So this is infinity to the power 0. In fact, if there be 1 to the power infinity, all will be like this way. This is the method to solve infinity to the power 0 or 0 to the power 1 to the power 0 and 0 to the power 0 form. So what will I do? So let L be the limit of this function. So L is equals to limit x tends to 0, 1 by x whole to the power tan x. We can write that. Now if I put log both the side, so it will be log L equals to log of limit x tends to 0 plus, it will be plus, all this will be plus. I forgot to write the plus. So this will be limit x tends to 0, log of limit x tends to 0, 1 by x to the power tan x. Now we can do what? Limit can, we can take limit outside. Since limit can go inside a function, so it can go outside a function also. So therefore limit will go outside the log. So it will be limit x tends to 0 plus log of 1 by x whole to the power tan x. Now since log of this is there, so tan x will come outside, so it will be tan x into log of 1 by x. Now we can see this is actually 0 into infinity form. So in that case, when 0 into infinity form is there, so in that case we will put the 0 form as, or the infinity form as the reciprocal, so that we can write it either in infinity by infinity form or 0 by 0 form. So let me take tan x, in the denominator it will become cot x, so it will be actually infinity by infinity form. Now we can write 1 by x as x to the power minus 1, so this minus will come outside and will give minus log x by cot x. Now this is actually infinity by infinity form. Now if I put use the L'Hopital's rule, the numerator's differentiation will be minus 1 by x and the denominator's differentiation will be minus cosecant square x. Now this 2 minus will be cancelled out, so therefore it will be 1 by x into cosecant square x. Now cosecant square x will go to the numerator and 1 by x, this x will come to the denominator, so it will be sin square x by x. Now we can write this sin square x by x as sin x by x into sin x, and we can distribute the limits also. So if we distribute the limit, this part will be 1 and this part will be 0. So therefore the limit of log L, this log L's value is coming 0. So therefore log of L is equals to 0, which implies L is equals to e to the power 0, since the base is e, and e to the power 0 is equals to 1. Hence this is the answer of this limit. Now you can also try some questions on limits on L'Hopital's rule. Now if there be any doubt, you can ask me the question in the comment box. So thank you for today.